Okay, in this video, we're going to look at something called variation. And essentially the idea is, in the real world, generally speaking, lots of quantities are related to each other. One quantity affects another. If I borrow a car, the monthly payment that I have on that car increases based off of how much I borrow. So the monthly payment is related to how much I actually borrow. If you're talking about a geometric shape, if you know the length of a rectangle and the width of a rectangle, the length and the width are related to the area. The bigger the length gets, the bigger the area gets, etc., etc. So since there's a lot of things that are related to each other, we have a whole class of problems that kind of deal with that relationship. And we call it variation. There's 3 different types of variation. They're all essentially the same, except for maybe how we solve them is the same, but we just write them slightly differently. So we're going to run through all of them and then look at some examples. So the first type of variation is what's called direct variation. And as far as the definition goes, we say this. Y varies directly with X if Y equals Kx. And this K right here gets a special name. It's called the constant of proportionality. Another way to say this, Y varies directly with X. You can also say Y is proportional to X. So that's called the constant of proportionality. And essentially the idea is, if I have some problem, let's say we say the area of a rectangle varies directly with the length. Then, as soon as I say that for all of these variation problems, as soon as you see Y varies with X, you immediately get an equation. So here, area varies directly with the length. If Y varies directly with X, Y equals Kx. Area varies directly with length. Area equals KL. And the good thing about these is you always immediately get an equation. In some of the other applications we've done, you've had to generate variables and then generate equations and then solve it. Here you get the equation by definition, you then just have to work with it. Because the way it works in math is, once you have an equation like this, that equation doesn't work until I have a value for k in there. So the next thing you're going to have to do when you have these variation problems is find the value for k. But when you're solving the problem, it has to say something like, the area of a rectangle varies directly with the length. Area is 20 when length is 5. And again, this all has to be part of the problem that's given, because then you can say, I need to find k. In order to find k, I need an a and an l that are related. But area is 20 when length is 5, so I can just plug in 20 equals k times 5. Divide the 5, and of course, k equals 4. So then I can rewrite my equation, a equals 4l. And now I have an equation. If I give you L, you can tell me A. If I give you A, you can tell me L. A lot of times when we solve these problems, we'll do this, and then we'll say something like, what is the area if L is 10? You just plug in and you're done and good to go. But the point is, as simple as this seems, this is how all of them will be. As soon as you see varies, you'll immediately get an equation for direct variation, y equals kx. And then you'll have to find k. You'll be given numbers to plug in so you can algebraically find k. And then sometimes, once you've found k, you'll be asked another question with more numbers to plug in to solve for one of the other variables. So, to kind of see a full problem, let's see, we will say the monthly payment on a loan varies directly with the amount borrowed. If the payment is $100, when I borrow $8,000, how much is the payment if I borrow $35,000? Okay. The monthly payment on a loan varies directly with the amount borrowed. If the payment is $100 when I borrow $8,000, how much is the payment if I borrow $35,000? And one thing I will point out, these word problems that we solve are actually probably going to be the most wordy of word problems that we go over, because we can have a lot of information in the problem. But don't get lost in all of that. As soon as you see the monthly payment on a loan varies directly, you're done. You can immediately generate an equation. And I would point out, as soon as you see varies directly, you can write y equals kx and then go from there. A lot of times I'll use letters that make sense in the problem so I don't get confused. So the monthly payment, I'll call that P. P is equal to K times the amount borrowed, I'll call that B. You can use whatever letters you want, I use those because they make sense. Now, I have an equation, but I need to solve for K. In order to solve for K, I need a P and a B that are related. And I'm told the payment is 100 when I borrow 8,000, so I can plug that in. 100 equals K times 8,000. So then K, just divide 8,000. 100 over 8,000 is equal to K, which is those zeros cancel, those cancels. 1 over 80. Now I rewrite the equation. P equals 1 over 80, and you can use decimals for this. My calculator's off over there on the shelf, so I don't have it right now. P is 1 over 80 times B. Now, generally speaking, you have a second question to solve, and in this case, how much is the payment if I borrow $35,000? Just plug in. P equals 1 over 80 times 35,000. And now I'll get my calculator just to check it. And we get 437.50. And there we go. And again, like I was saying, while these problems can be incredibly wordy, they're actually the easiest problems we'll solve, because as soon as you see varies, you immediately have an equation, and then you have to be given information to solve for K in that equation. And then if they want you to solve anything else, they have to give you the other numbers, and the rest of it is just really button pushing on a calculator. So, to make these a little bit more entertaining, like I said at the beginning, there's actually different types of variation. So, the second type of variation is called indirect variation or inverse variation. And all we say, y varies inversely with x if y equals k over x. This is the exact same as direct variation. We still have a constant of proportionality k. The only difference is, well, instead of multiplying, I divide. But other than that, the method of solution, the problems will all be identical. You'll be told y varies inversely with x. You immediately get an equation, y equals k over x. Then you need to solve for k. So you have to be given an x and a y that are related. Plug in, solve for x. Solve for k, I'm sorry. Once you have your k, sometimes you're asked to solve another equation. I'm not going to do an example of this because it's identical to the last one we did. We're going to look at the third type of variation, and then we'll solve some more general problems. The third form is joint or combined variation. And the way it works, y varies jointly with x and z if y equals k times xz. And again, it's the exact same as the other variations we've done. We have my y, we have my constant k. The only difference here is now I'm varying with different quantities, and they just get multiplied. Before we had y equals kx, now it's y equals kxz. The idea being in the real world, while a lot of times there are two quantities that are related, in actuality, there's usually like 17 different quantities that are related. So we need a way to combine all 17 quantities, and we use this. From your perspective, all that really matters is, if something varies directly or jointly, you write y equals k, and you multiply by all of those things. If it varies inversely, you divide by all of those things. And that's it. I'm going to do a quick example here, and then I'll make another video doing some problems from your book. So, suppose we say y varies jointly with x and the square of t, and inversely with the root of L. Find an equation relating these quantities if y equals 10 when x equals 2, t equals 3, and L equals 16. So I have a whole lot of information there, but the only thing that really matters is y varies. As soon as I see varies, I know I get an equation, and I can just fill it in. Y equals k. And now let's see, anything that varies jointly gets multiplied. So it varies jointly with x, multiplied by x. And the square of t, that's t squared. And inversely, anything varying inversely gets divided with the root of L, which is the square root of L. And one thing I will point out, you do not need several different constants when you do this. You just have one k. So there's my equation. X and t squared get vary directly. The root of L varies inversely. So I have an equation. Now I just need to find the k value. But in order to do that, I plug in everything listed. So let's see. I get y is 10 is equal to k times x, which is 2, times t, which is 3 squared, all over the root of 16. So 10 equals k times 2 times 9. Square root of 16 is 4. And then let's see, the 2 will cancel with the 4 and leave a 2. And then to solve for k, you multiply the 2. 2 times 10 is 20, equals k times 9. So k equals 20 over 9. And then my equation becomes y equals 20 over 9 times x times t squared, all over the square root of L. And then of course the next step would be, maybe I give you a t and an L, and you have to find y. And it's just plugging in and hitting buttons on a calculator again. Okay, I'm going to make another video where I actually do a couple of problems out of your book so you can see them worked out too.